Hello friends, today we are discussing 2 degree of freedom system. So first of all, let us understand the configuration. Here we have two masses which are interconnected by these three springs. The system we are considering is undamped free vibration system. So here we are not having any damping and also we are not having any forcing function on these masses. When these masses vibrate, let us assume that the displacement of mass m1 is x1 and displacement for mass m2 is x2. Similarly, these masses will be having the velocities x1 dot and x2 dot and acceleration x1 double dot and x2 double dot. So the right side we are considering as positive displacement. So first of all, we will learn how to write the equation of motion. So to write the equation of motion, we need to draw the free body diagram of each mass. So let us start with mass m1. So this is mass m1. When we are giving some positive displacement to mass m1, the, the spring on the left hand side of mass m1 will be in tension and it will exert some force on mass m1. That will be k1 x1. Similarly, uh, spring K2 will also exert some force on mass M1. Let us assume that displacement x2 is larger than displacement x1. So, in this condition, spring K2 will be in tension. So, it will exert a force K2 x2 minus x1 on mass M1. From Newton's second law of motion, we know the sum of forces acting on a point mass will be the product of mass and acceleration. So we will write down what are the forces acting on mass m1. So a1 x1 plus k2 x2 minus x1 will be equals to mass m1 and its acceleration, that will be x1 double dot. So from here we will get the equation of motion for mass m1. This is the equation of motion for mass m1. Similarly, we will draw the free body diagram for mass m2 and try to write the equation of motion. Since we have assumed that the displacement x2 is larger than displacement x1, so the second spring will be in tension. So this will exert the force k2 x2 minus x1 on mass m1 in left side direction. Since we are giving x2 displacement to mass m2 in right side direction, so third spring will be in compression. So this will exert force K3 x3 on mass m2 in left side direction. So this is the free body diagram for mass m2. So we'll use our second law of motion. So for mass m2, for mass m2, the forces which are acting on it are k2 x2 minus x1 minus k3 x3 equals to m2 x2 double dot. So this gives us m2 x2 double dot minus k2 x1 plus k2 plus k3 x2 equals to 0. This is the equation of motion for mass m2. So if we want to write the equation of motion in matrix form, we can do that. So let us see how we can convert these equation of motion in matrix form. So we write these two equations together. Let me write them again. So we will write these equation of motion in matrix form. This matrix we call mass matrix, and this matrix is called stiffness matrix. In short, we can write m x double dot k this matrix form is nothing but a system of linear equations. So if you open these matrices, you will again get the same equation of motions. First line will give you the equation of motion for mass m1, and the second line will give you the equation of motion for mass m2. These are nothing but a system of linear equations. So here in this video we have seen how to draw the free body diagram and to write the equation of motion of a 2 degree of freedom system which is not experiencing any damping or any forcing function. Thank you.